This video covers a reaction coordinate diagram for a two-step reaction. Moving left to right on the x-axis, we're going to start with reactants, then we'll see our first transition state, symbolized by the double dagger symbol. Then we'll get our intermediate, onto the second transition state, another double dagger, and finally the product. On the reactant side, we have 2-bromo, 2-methylpropane, and chloride ion. On the product side, we have 2-chloro, 2-methylpropane, and bromide ion. So what's happening in this reaction is the chloride is replacing the bromide. But this reaction happens by two steps. The first step is loss of a leaving group. The bromide ion leaves, giving you this carbocation and bromide. So the carbocation is your intermediate. In the second step, chloride attacks the carbocation that was generated in the first step to give us our product, 2-chloro, 2-methylpropane. The sum of these two steps yields the overall reaction, which is just simply 2-methyl 2-bromopropane plus chloride yields 2-methyl 2-chloropropane plus bromide. The graph shown below is the reaction coordinate diagram, with the vertical axis being delta G and the horizontal axis being progress. The reaction coordinate diagram has two humps corresponding to each of the steps. Here's step 1, the loss of a leaving group. And here is step 2, the nucleophilic attack. Our reactant is the starting point along the horizontal axis. Our first transition state is at the top of the first hump. We'll call that double dagger 1. Our intermediate is in the trough. Our second transition state is at the top of the second hump. And then our products are at the end. So now we can fill in the structures present at each point. There are our reactants. There's our carbocation intermediate, and the bromide ion, and the chloride ion. And our final product, we have the 2-methyl 2-bromopropane, the 2-chloro 2-methylpropane plus the bromide ion. Here's a zoomed in view. So the next question should be, what is the nature of the transition states? Since chemical bonds break and form during a chemical reaction, we postulate that the transition state exists in between the reactants and products at the peak of the reaction coordinate diagram, where the bonds that are going to break are roughly halfway broken, and the bonds that are going to form are roughly halfway formed. Thus, transition state 1 shows the CBr bond in the process of breaking. That's what the dashed line means. Also, this will mean that formal charges are in the process of forming. So we'll have a delta plus on the nascent carbocation and a delta minus on the bromide ion that is being formed. What should the transition state 2 look like? Remember, here we're forming a bond between the carbocation and the chloride ion. Pause the video now and sketch what you think the transition state looks like. Then, when you're done, you can unpause and take a look at my answer. Here's what I get for the second transition state, double dagger 2. Here. As you can see, I've got a chloride ion forming a bond with the carbocation. You may notice that I've drawn the bond that is being formed longer than I drew the bond being broken in double dagger 1. This is because of the Hammond postulate, which simply says that the closer 2 points are on one of these reaction coordinate diagrams, the more alike they are. Thanks for watching the video. How do you think it would be different if our overall reaction looked like this? Would it be exothermic or endothermic overall? What about the height of the two humps? Remember, a CCl bond is stronger than a Ci bond. Thanks a lot for watching my video.